In this video, we are going to continue our discussion of vectored value functions by integrating said functions. This is nice. I don't have any theory to connect this. We could. Really how it's going to work, just like derivatives, we took the derivative of each component. Integration is exactly the same way. I would recommend taking each one and breaking it down and doing it piece by piece. This first one's not too bad. Like even in my notes, I didn't break it down like this, but I think leading into the next couple problems, this is going to help quite a bit. Now, our integration power rules, remember we go up by 1 and divide by the new one, so we get 3/4 t to the 4th, and then we're going to run that from 0 to 1. So I'm going to plug in 1, and then I know that this one's just going to give me a 0, but I'm going to write it anyway for your notes. So the answer for this one is 3/4. So I know that's the answer for the I component. Now I'm going to do the J component. Don't forget, I know I see this in Calc 1 a lot, in Calc 2. People forget that. That's going to be extremely important this semester. We're going to have multiple of those. So if you leave that off, I will count off. Not very much. I just need you doing it. And you'll see here in the next chapter or so, you'll see why that is so important. Okay, so following this integration rule, I go up by 1, t to the 6th. I divide by the new one. That is negative 2 over 18, which is a negative 1/9, t to the 6th, running from 0 to 1. I'm not going to plug it in just to keep help with the video time. If I plug a 1 in, 1 to the 6 is 1, 0 gets me 0. I get a negative 1/9. I think that one's easy enough to see. And then our third one is 0 to 1 of t to the 4th dt, which is going to be 1 over 5 t to the 5th. We're going to run that from 0 to 1, so we get a 1/5. So this integral is equal to 3/4 I minus 1, pencil's coming apart, minus 1/9 j plus 1/5 k. So I would recommend breaking them apart like that each time, so you can work on your integration techniques. If you can't do this, we need to talk. We have quite a bit of integration to catch up on. All right, let's do another one. This one's going to require a few more methods than the first one did. All right, so breaking this down, let's do the first one. I got the integral of t times cosine of t squared minus 3 dt. All right, we're going to use a u substitution here. If I let the argument of cosine be that, then my du is 2t dt. I don't have a 2, so I'm going to divide by 1/2 on both sides. And now I know that I can replace t dt with 1/2 du. Okay, so let's do our replaces. This and this is going to get replaced with 1/2, 1/2, and then du. So I'm going to have cosine of u du. Everything got replaced. Everything is in terms of u now. So I get negative 1/2. The derivative, the reason the negative came from is integral of cosine. Ooh, let's be careful here. The integral of cosine is sine u plus c, 1. We should replace u. So I got 1/2 of sine times t squared minus 3 plus c1. That is my I component. Okay, so that's the first one. Let's do the second one. So it's the integral of negative t sine t dt. This is going to require integration by parts. Integration by parts is uv minus the integral of v du. And then I need to assign a few things to make that work out cleanly for us. So the point of integration by parts is you want to let u be something that can be taken away by a derivative. I'm going to take this negative that's out front though, and I'm going to move it out front, way out front. That way I don't have to deal with it. So I'm going to put a t here. The reason I knew to put a t there is because I know the derivative is 1 dt. meaning I got to put a sign here. We always do this one and this one. Take the integral to go backwards. I put the dt with that one. Sine dt, the integral is negative cosine t. And then I follow the rule. Okay, I got a negative. I'm going to put this in parentheses. That was the negative from way out front. I multiply negative uv, so I got negative t cosine t minus the integral of negative cosine t dt. Okay, the negative, okay, so I get t cosine t, and then I'm going to have a minus. Minus makes a positive, but the minus out front is going to make a negative. And then that integral is sine t plus c2. All right, we have one more integral here. The integral of t e t squared dt. This is another integration, u sub. Let u sub be t squared. It's a direct one. So du is t dt, but we don't have a 2, so it's going to be 1/2 du equals t dt. All right, and we can replace. It's the integral of, okay, the t dt is taken care of, so we got e to the u bu, which is just e to the u plus c3, and then we replace our u with t squared plus c3. Okay, so this integral is equal to, let me shrink all this down. All right, the integral is equal to, let's move all of that actually, equal to, okay, we get the I component, so I'm going to put that whole thing in parentheses. Oh, we can replace our u, I forgot, minus 3 plus c1 I. Plus 2t cosine t minus sine t plus c2 j plus e to the t squared plus c3 k. Okay, so that is how we integrate with some stickier integrals, integrands, meaning the argument inside the integral is called the integrand. Integration by parts is going to show up. You're going to be expected to be able to use it. U subs are definitely going to show up, and you need to be able to use it. A few techniques, and I will post some review. You'll have that in your course in some way. I'm going to say it very vaguely because these videos are going to be applied to many semesters. So it may depend on how I decide to review integration with each class. Okay, we have one more here. We're going to do each piece by piece again. So the integral of 6 over 1 plus 4t squared. And I try to make the u sub obvious here. The u sub would be the inside of that square. We're always looking for that, especially when I have these 1 plus squared on the bottom. So du then is 4 dt, which means that 1/4 du is dt. All right, so we can go ahead and replace now. I got the integral of, and let's let all our constants actually come out. I got 6 times 1/4 integral of 1 plus 1 u squared du. So this is equal to 3 over 2. And then the integral of 1 plus 1 over u, that's the inverse tan. So we have that plus c1. And then I got 3 over 2 tangent, and then we replace the u with 4t. So there is the answer to the first component. Second component. All right. U then is 12 minus t squared. Right? The reason I know to do a u sub here is because when I take my du, I get left with negative 2t dt, and that's going to take care of my t. So 1/2 du equals t dt. That's solving for that. Okay, so now I can replace. It's the integral. It's 1 over u. Oh, don't forget your negative 1/2 here. du. All right, that is negative 1/2 ln the absolute value of 12 minus t squared, that's u, plus c, 2. Let me do another one of these with u in for your notes. So u. Make sure that is one thing that's missed a lot, is the integral of 1 over u is actually the ln of the absolute value, because I can't take negative. That's important because the argument actually could be negative if you let t be bigger than the square root of 12 or smaller than the square root of 12. It will give you an ln of a negative, so we need that absolute value. All right, we have one more, which is a pretty straight up one. It's the integral of 1 over the square root of 1 minus t squared dt. This is a table problem. You'll have a table that will help you with these kind. So this is sine of negative 1t plus c3. So the integral, we'll just do that to be lazy, is 3/2 tan, arctan of 4t plus c1 I. Okay, I can zoom back in now. I'm going to make this a bit smaller, scoot it over at least, plus negative 1/2 ln of the absolute value of 12 minus t squared plus c2 j, and then plus inverse sine plus c3 of k. So that is our integral. Integration of vector value functions literally is just straight integration, but 3 times, meaning that you need your integration techniques, integration by parts, u subs, the dreaded trig sub, those kind of things. I won't throw a lot of trig subs at you, but it could happen. Typically, I stray away from those because I end up having to write a bunch on the problems because nobody typically can remember how to do the trig subs. So if they do show up, more than likely trig subs will show up in homework. Could show up on a test, but it's unlikely. Go review these integration techniques now before we get to where it's heavier. It is going to get to a point where it's going to be much heavier and you're going to be balancing integration with new topics. This vector stuff isn't really new except for the 3 component thing. So use this time to review. Don't wait until you realize, oh crap, I failed that test and now I need integration. Go ahead and get the review in any way you see fit.